In the previous video, we discussed the reasons onions make you cry. If you haven't watched it, I advise you watch it. It's right here on my channel so as to avoid getting confused or lost about what we're trying to illustrate. In this video, I'm going to explain the chemical reactions that take place from the moment an onion cell gets damaged, the moment the eyes start tearing up. And of course, all that will be done with the help of a molecular model kit. So let's get started. When onion cells are damaged, the propanol cysteine sulfoxide in the cytoplasm gets in contact with the enzyme allinase that was in the vacuole. As soon as they get in touch, the enzyme allinase breaks down propanol cysteine sulfoxide to propanolsulfonic acid, pyruvate, and ammonia. But how does this happen? Now, when you look at propanol cysteine sulfoxide, this is the molecule of propanol cysteine sulfoxide. You'll notice that it actually consists of three parts. The alkyl group, this right here is the alkyl group, which in this case is propanol. This is propanol, and also an amino acid backbone, the amino acid being cysteine. This right here is cysteine, and finally a carbon sulfur bond right in the middle, which links the cysteine part to the propanol part. What the enzyme allinase actually does is it breaks the carbon sulfur bond, this bond between the beta carbon of cysteine and the sulfur atom. For those that don't know what a beta carbon is, a beta carbon is a carbon atom that is two atoms away from a functional group. So we're counting 1, 2, 3. This is two atoms away, so this is the beta carbon. So it breaks down this bond, and while this bond is breaking, this right here, which is the amine group, gets released, leaving the imine carbon exposed. Water then takes advantage of the situation. Since this is exposed, it's vulnerable, it attacks it, so it breaks this amine, this repositions itself to here. Then the oxygen from water, the oxygen from water attaches itself to this carbon, to the imine carbon, this imine carbon. Why are they so hard to actually put together? Or maybe I'm just weak. Okay. This right here. This is the oxygen from water. So it forms a carbon-oxygen double bond. And what we literally have right here is pyruvate. So basically the cysteine part breaks down to ammonia and pyruvate. Remember, we still have this whole part. This is the part that tends to propanolsulfonic acid. And of course, that happens through protonation. But where does the proton come from? The proton can come from an active site acid residue, or from proton relay network, or from solvent water. Anyway, when protonation occurs, this right here opens up and we have a proton attached to the oxygen, and we end up having propanolsulfonic acid. So this right here is propanolsulfonic acid. So another atom called lacrimatory factor synthase acts on this propanolsulfonic acid to form propanethyl S oxide. And how does it do this? What it actually does is it breaks down this oxygen-hydrogen bond. After breaking down this oxygen-hydrogen bond, this hydrogen migrates to the alkane, this alkane right here. So it migrates to this alkane. As a result, this double bond shifts because it becomes saturated. So it shifts to in between this carbon and this sulfur. Let me just do that real quick. So this shifts, this double bond shifts to in between the carbon and the sulfur. So we have this hydrogen right here migrating, making the alkane saturated. As a result of that, the double bond shifts to in between the carbon and the sulfur. Why can't I put this in? Wow, this is so hard. Ooh, I'm failing to put this in. I don't know why, but ooh, this is so hard to put in. I don't know why. Should I try from a different side? Let me try from this side. So, am I this weak? Okay. Whew, finally we have it in. Okay, so now we have the double bond between the carbon and the sulfur, and as a result of the double bond being between the carbon and the sulfur, instead of it being in between these two carbon atoms, this sulfur and the oxygen also end up gaining a double bond character. And how does that happen? That's actually another topic, another thing. That's another thing. So let's just know that that's what happens. Yeah. Then as a result of all this, as a result of all these atom rearrangements, we end up with propanethyl S oxide. So this right here is propanethyl S oxide. What we now have is propanethyl S oxide, and this molecule, being very volatile, rises into the air and unfortunately manages to reach your eyes. It actually rises into the air like everywhere, but it's mostly the eyes that can feel it. Yeah. So, and the eyes being moist, I mean, they naturally contain water. So the water in the eyes react with this propanethyl S oxide and form sulfonic acid, which irritates the eyes. And so the eyes end up producing tears to try and flush out that irritant, which is sulfonic acid, because it irritates the eyes. Yes, so if you found this video to be helpful, please like, subscribe, comment, and help share the video. See you in the